well. My name is Riya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Relevel. So in this video, after having taken an introduction about ER models and what are the basic things that we need to do about ER diagrams, now we are going to take a deep dive and understand this topic in a little bit more detail. Now we understand the theory, right? We understand the basics, we understand the terminologies, but it's also important to get a little hands-on and talk about how we can actually create the ER diagrams. How do we visualize the ER models? So let's quickly get started on that. So let's talk about a basic definition first. ER diagram is a virtual representation of data that describes how data is related to each other, okay? How actually the data is going to be related with each other. In ER model, we disintegrate data into entities, which we talked about, and attributes, and then set up relationships between them, okay? For example, we talked about that school management software in which the data was disintegrated into entities. For example, entities were school, teachers, class, subject, and their attributes, and then we had a relationship. For example, each student is going to be a part of some class, and all this can actually be represented using the ER diagrams. For example, in the above diagram, you can see over here that if you want to convey that developer develops a website, right, whereas a visitor visits a website, okay? Look over here. So what kind of a relationship are we trying to display over here is that developer creates website and visitor visits website. So visitor, developer, and website, all these three are entities and all of them are having relationships. Visitor is having a relationship with website in the sense that visitor visits website. Developer and website are created with each other in the sense that developer creates website. So this is what typically in a very bare minimum idea what a ER diagram is. Now we are going to understand a few key components around it. You must be seeing we have some rectangular boxes, we have some pentagon diamond kind of a boxes, right? So we'll understand what is the meaning and what are the key things you understand to actually make a ER diagram. All right, so let's quickly get started on that. First, like I said, we'll talk about the components. Entity, attributes, relationships forms the components of ER diagram, and there are defined symbols and shapes to represent each of them. Like I told you earlier, right, we were using a rectangular box, we were using a diamond box. So it's not like you can use them interchangeably or you can use any way you want. There is like a particular way, of defining which shapes represent what part, okay? So we'll talk about how do we actually represent these in our ER diagram. So first we'll talk about entity. Always remember that a simple rectangular box basically represents an entity, right? Here also you can see that whenever you use an rectangular box, it automatically means that you are representing an entity with that, okay? So that is why here website, visitor, and developer are entities, and the example shown over here, students and subjects, if you consider a school management system, students and subjects basically form the entities. Then we talk about a relationship between entities. You must have seen over here that we were using diamonds boxes over here to represent the relationship between the entities. Now the thing is, when you try to represent relationship between the entities, relationship can actually be of two types. A relationship could be a weak relationship or it could be a strong relationship. So a rhombus shape is used to represent relationship between two or more entities. If the relationship is a simple rhombus box, it is a normal relationship. Whereas if you have two rhombuses stacked inside one another, then it is a weak relationship. We'll talk about more into that in detail. Now we'll talk about the attributes which are represented or a part of any entity. So eclipse is basically used to represent attributes of an entity. So I told you each entity has multiple attributes, right? For example, if it's a student entity, it has attributes like name, age, phone number, correct? Similarly, here you can see that there is an entity called book and it has attributes like author, date of publish, probably number of pages as well. So to represent the attributes of an entity, we use an ellipse shape over here. Inside it, we write the attribute and connect it to the entity. Then we also have the concept of weak entity. Now, similarly, we have weak relationships. Similarly, we have weak entities as well. Okay. A weak entity is represented by double rectangular boxes. So a normal entity is represented with a normal rectangular box, but a weak entity is represented using double rectangle boxes, and it is generally connected to another entity. So it's like you don't have this entity as an independent. A weak entity is usually connected to a strong entity. Next is key attributes for an entity, right? You remember we talked about keys, right? So for example, we have an attribute which is a key, right? For example, in the school management system, for the student entity, roll number is a key entity, right? Because it uniquely identifies a student. Similarly, if you have a key attribute, the attribute is obviously written inside an ellipse because it's an entity attribute, but you have to underline it as well, mentioning that it is a key entity. Okay, I'm just talking a little bit about the symbols that you have to use over here in order to represent the entities. Okay. Next, we've already talked about derived entity. You remember we took the example of average age, right? That's a derived entity. To represent derived entities, right, we basically use, attribute is always in an ellipse, but if it's a derived attribute, you have to put dotted ellipse inside the main ellipse. Okay, and derived attributes were those attributes which are derived from a simple or a composite attribute. For example, I can say if you have age, right, age is a derived attribute if date of birth is given to you. So as such, age is not present in the database system, but since date of birth is present, from that you can derive age. Next is multi-valued, right? Double ellipse basically with both solid lines, no dotted lines. Double ellipse, one inside the other, represents the attribute which can have multiple values. For example, when we store phone number for a particular student, we can have multiple phone numbers. So that is why we have a double ellipse. Then we have composite attribute. A composite attribute is the attribute which also has like simple attributes, and accumulation of that is a composite attribute. So how do you represent it? You take multiple attributes, you connect them to another ellipse, and that's how you make the composite attribute. Okay, which is a connection of multiple simple attributes. Next, we talk about how do we understand ER diagram in terms of entity. So an entity can be any object, person, place or class, like we talked. It's any real world object which is of our concern. In the ER diagram, an entity is usually represented using rectangles, which we've talked about. Now consider an example of an organization. We have an employee, we have a manager, we have a department, we have some products, and many more can be taken as entities, right? If we are talking about a company as an organization, employee, management, department, product, finances, business, all of these are entities, correct? So how do we represent it? That employee and department are two entities. How the two of them are related to each other? That employees work for a department. So the relationship is represented with a rhombus, right? And employees are a part of a department. Okay, so the yellow rhombus in between represents a relationship, and we remember that we represent relationships in a rhombus, right? So that is what we have used it for. Then we have a weak entity, right? We remember that weak entity is simply a box inside, a rectangular box inside another box. A weak entity is an entity that depends on another entity. So like I told you earlier also, a weak entity cannot exist by itself. It's an entity that is dependent on another entity. Okay, Weak entity does not have any key attributes on its own. You remember every entity has attributes, and one of those attributes is usually a key attribute. But when we talk about weak entities do not have key attributes of its own. Okay? Double rectangle is basically used to represent a weak entity, right? That is what we talked about. Then we talked about attribute. Now we are kind of putting all the things together now. Now an attribute describes a property or characteristics of an entity. Okay, like we've already discussed. For example, name, age, address are all attributes of a student. Okay, an attribute is represented using Eclipse right over here. So student is an entity, and connected to that we have multiple attributes. Name is an attribute, address is an attribute, ID is an attribute, and age is an attribute. Now if you think of it over here, can I say that I can put an underline below ID? Yes. Because when for an attribute you do put an underline, that means it is a key attribute, which in this case makes sense as well, since ID can definitely be a key attribute. Okay. Similarly, address can be considered as a composite attribute, right? Using that, we can put more attributes on top of it. So let's take a look. Let me give you an example for that. Okay, now it should be good. Right, let's see. So far we saw that we have a student, which was an entity. So it's inside a rectangle. Then we have address. We have age. We have ID. And we have name. So we can put underline below this, mentioning that this is a key attribute. And we can think of address as a composite attribute, which let's say is derived from street address, pin code, city. Okay, it's not mentioned in the slides, but like I said, it's always good to know all the concepts. So you can think of it like this as well. Okay, and represent all attributes using an eclipse. Then we have key attribute, like I just talked about. Key attributes basically are the main characteristic, right? How do we uniquely identify a particular like a data set value in an entity? So it is basically used to represent a primary key, and eclipse with the text underlined basically represent the key attributes. In this case, which is going to be the ID. Next, we have composite attributes, which we just introduced as well. Now, an attribute can also have their own attributes, right? That's what a composite attributes is. So in this case, for address, we have city, we have state, and we have zip. Okay, so that is how we represent this. So I hope this is clear to everyone. This was mostly focused on talking a little bit about, how do we represent entities, how do we represent relationships, and how do we represent attributes. Okay, in the follow-up part, what we will talk about is that how do we represent relationships. Okay, now a relationship basically describes the relation between entities. Okay, and a relationship is basically represented using diamonds, right? Using, I would say, diamonds or rhombus, whatever you can call it. Now a teacher and a student. Now a teacher teaches a student. So a relationship inside the rhombus. So when we talk about relationships, there are 3 relationships that actually exist. One is the binary relationships, then we have the recursive relationship, and then we have the ternary relationship. When we talk about binary relationship, it means relation between 2 entities. Okay, then we could have one-to-one relationship, one-to-many relationship, or many-to-one relationships like that. Okay, so this type of relationship is rarely seen in the real world. Okay, the above example describes that one student can enroll for only one course, and a course will also have only one student, right? This is just for example, but you will see that it rarely happens in the real world, right? A student can enroll in multiple courses and a course can have multiple students as well, correct? But here, just to representation, we have seen that how when we represent binary relationship, that means it has two entities only, right? And the relationship between them also, between two entities, can be of many types. And the first of them is 1-to-1. Okay, wherein one student can be a part of only one course and a course will have also one student itself. All right. But usually this is not what we see in real world relationships, is what is mentioned over here. Okay. Next we have one-to-many relationships. Now the below example showcases this relationship, which means that one student can opt for many courses, but a course can have only one student. Again, that is weird, right? But this is how it is. Just for example, we've seen that when we say one-to-many, that means one student, right, can opt for many courses. I can opt for math, science, English, SST, but the courses will have only one students. Okay, so one-to-many. Next is many-to-one. Okay, so that means this reflects the business rule, okay, that many entities can be associated with just one entity. For example, a student enrolls for only one course, but the course can have many students. So I as a student, right, will enroll for maths, right? My friend Aman also enrolled for maths. My friend Shikha also enrolled for maths. Okay, so I enrolled for only one course, right? When you go for, let's say, maths tuition, so you enroll for maths tuition, just one course, and the maths tutor is teaching a lot of students. So the instructor has a lot of students. The course has many students. That is many-to-one relationship. And many-to-many, this is what the real relationship is. I can enroll for multiple courses will have multiple students. I can enroll for, let's say, English, Hindi, maths. My friend Aman can enroll for, let's say, SST, English, Hindi. My friend Shikha can also own for multiple courses, and those courses have many students as well. Okay, so this is like many-to-many kind of a relationship. Let's quickly reiterate on that once again. So when we talked about binary relationships, that means first of all, it will only have two entities, okay, and one relationship between them. But the relationship could be of many times. One-to-one, one student can be a part of one course will have only one student. One-to-one. One-to-many. Student can enroll for multiple courses, but every course will have only one student. One-to-many. Many-to-one. Students can enroll, right, for just only one course, but the course will have many students. Many-to-many. Students can enroll for multiple courses. All courses will have more than one students involved in it, okay, or enrolled in it. That is many-to-many. So this is about binary relationship, okay. Next is recursive relationship. When an entity is related with itself is known as a recursive relationship. An employee manages, right, employees, correct? An employee, let's say I am an employee and I have 3 more employees who works under me. So employees manages employees itself. That's like a recursive relationship. Okay, when an employee has an entity has a relationship with itself. Every employee manages itself, so it's like a recursive relationship. Ternary relationship. Now the relationship of degree 3, right, where 3 entities are involved, is known as ternary relationship. Now a ternary relationship involves 3 entities. In such relationships, we always consider 2 entities together and then look upon the third. So 2 entities will be considered together and then they will look upon the third entity. The above relationship, as you can see, involves 3 entities, right? Companies operate in sector producing some products. This statement is very, very important. Okay. Companies works or operates in sectors, right, producing some products, right? Every company produces some products. Okay, so that is what the overall idea here is. For example, we just saw in the diagram above that we have three entities: company, product, and sector. To understand the relationship better, or to define rules around the model, right, we should relate the two entities and then derive the third one from that. So a company produces products, and each product is produced exactly by one company. Okay, one company can produce many products, right? As a company called Sony, I can produce TV, I can produce headphones, right? And I can make mobile phones as well, right? But the other thing is that every product is made exactly by one company. So Sony will only make headphones, no other company will. I will only make TVs, no other company will. Sony will only do that. Okay. Now, other thing is, a company operates in only one sector, and each sector has many companies operating in it, right? Let's say I am a company, let's say for detergent. So I am just operating in the sector for detergent, okay? And there are many companies which are working in the sector of detergents. Now, comparing the above rules of the relationship, we see that although the complete relationship basically involves, you can see over here, all the three entities, right? But at a time, you are just looking at two entities. In the first one, you're just looking at companies, right? And products, right? And in the next one, you're just looking at companies and sector, correct? So, using the two relationships, you derive the third one. That is what ternary relationship is. You don't consider all three of them together. You consider two at a time only, and using that you derive the third one. Okay, so this in its sense should be the building blocks that will actually help you to make ER diagrams. Okay, ER diagrams become a very important and a very, very crucial part of the entire modeling procedure, and to actually move forward and understand the entire databases and draw relationships between them. So it's equally important that you use the right symbols, you use the right keywords, you use the right notations in order to represent the relationships as well as the entities and as well as the attributes. So just to quickly summarize what we did over here today, I'll just quickly move back to the start and move on that. So this is a basic diagram where we represented entities and attributes and relationships, not attributes over here, right? We talked about how an entity is in a rectangular box. Then we talked about weak and strong relationships, right? We'll go more deeper into this later, right? Then we talked about attributes. So entities in rectangular box and relationships in a rhombus box and attributes in eclipse. If it's a strong entity, one box, rectangular box. It's a weak entity, right? Then it's two rectangular boxes. If it's a strong entity, one rhombus. If it's a weak entity, two rhombus nested inside one another. If it's a strong attribute, you can see weak entity, the example that I just gave, right? If it's a key attribute, you have to put it underline. If it's a derived attribute, you have to put in dotted. Okay. If it's a multi-valued attribute, you have to do this. Okay. So this is how it basically works. Box for strong, weak with this. Relationship, strong with this, weak with this. Attribute works a little differently. A normal attributes like this. Derived attribute is like this. Multi-valued is like this. Okay, so that is how it basically works. And then we have composite as well. Okay, these are composite attributes. And this is just an example where we saw how employees work for a department. And weak entities are always dependent on another entity. And this is just a ER diagram where we have mentioned the key as well. Composite attributes, and here we have relationships. So we have three types of relationship. We have binary. In binary we have 1-to-1, where one student, one course, every course, one student. One to many. One student, many courses, every course, one student. Many to one. One student, one course, but a course will have many students. Many to many. Many students one student can take many courses, a course can have multiple students. Recursive. This is typical how the concept of recursion works, right? You have a relationship with yourself itself. And then we have ternary. Ternary have three attributes involved. And using two attributes, we derive the third one. So at a time, we only take up one attribute only. Okay. And using those two, at a time, we only take two attributes. And using two attributes, we derive the third one. Okay. So this is what it is. I hope it helps you to understand. Right, I've given a quick overview and summarized this as well for you to take a look. But I think the best way to fully understand is not just to watch the video and take a look at the slides. You actually have to get some hands-on on this. Take a small example for maybe, let's say, an organization, for a school management system, right, for a society, anything you want. Take a very small example, try to identify the entities, right, try to draw relationships, represent them, draw them on your own, try to identify the composite attributes, try to identify the key attributes, weak entities, strong entities, and pave your way forward from there, right? Because that's how you actually learn over here. It all comes with practice. If you do it one time, you study it one time, you'll forget it later if you don't practice. So the key over here is to practice, make an effort, go move ahead, right? See how many relationships can you really draw, and then, see how much content can you grasp actually from there. And once you move forward in this way, it actually helps you to understand whether the grasp on your concepts is really good or not. Because if it's not, then you will have to, take a look at it again and go for it. But once you make it a firm idea that you've learned it in your mind, it stays in your head forever. Okay? Alright then, thank you so much for attending this. I hope you had a fun time understanding this topic and I could make it a little bit easier for you to understand. My objectives in the video are to always make this journey a little bit easier for you with some good real life examples and giving some occasions for you to, try it out once on your own as well, and giving you the opportunity to fully learn. So I hope I was successful in that, and please keep on practicing. Try out a few examples on your own. Thank you so much, and I will definitely meet you in the next video.